So on this, you're only putting in today, welcome, on this warm-up, we're only going to put 2 in each of these. Is this something your calculator could do for you? Dang right it is. You don't have to. You can do that. You can plug it in, do the math. Earlier today, I just put all 3 into my calculator. And if I put in the value 2 for x in all places, I got 7 on the first one. Anybody get 7? Well, that does mean that you can plug it in incorrectly into a calculator. So you got to be careful. We'll have to retry. I got 7 as well. On the second one, 3 times 2 minus 7 squared minus 6 gave me 69. What did I give you guys? And on the third one, negative outside 2 plus 3. Oop, went off. Come back. 2 plus 3 times 2 minus 7. I got 15. So let's go back to the first one where some of us got a different number. Tell me how to type it in that might get it.
I did it wrong. I put in negative instead of a minus.
Oh, okay. So let's say if you went 2 times 2 squared, and if you hit a negative sign, it looks like that, doesn't it? Negative 3 times 2 plus 5. If you plug it in like that, where right there is a negative sign instead of a minus, hey, guess what? You do get negative 43. So that is definitely one of the easiest mistakes to make when you're looking at a calculator. Do not use the negative sign as a subtraction sign, but use the subtraction sign where you plug it in. I've made that mistake before. Has anyone else ever made that mistake? It's an easy mistake to make. All right, turn the page. Welcome to quadratics, quadratic functions. If you were to look, follow my finger, look that way over there on the wall, look over there. There are some signs that deal with algebra 2 quadratics. We are finally into this stuff. Okay? What makes a function quadratic? So how do we now become a set of, what have we been in up until this time? What kind of functions? Somebody say, I know you know. Linear, very good. So finally, for the first time, we're going from linear, out of linear world, into quadratic world. So yeah. It's like you've played a video game forever, and you finally, after years and years and years, you found a new, give me a word here. Found a new achievement. What else can it be? Like if you get to the next world or a new level, would the level be? Now, wouldn't that be crazy? When let me tell you how old I am. I haven't played a lot of video games, but when I was a little kid, we played Mario Brothers, obviously. Y'all probably know Mario Brothers. I mean, I think everybody plays it at least some, right? Maybe. And on Mario Brothers, man, I tell you what, it was so cool when you like jumped up on top of the wall and like you walked and you found like this hidden level thing and you go down a pipe and it warp zone you over to something else. You're like, oh, I just broke the system. That was a pretty cool feeling as a kid. All right, so here you're traveling through time into a new era of mathematics for you. Doesn't it feel exciting? Okay, check it out. Standard form of a quadratic. There's just a few things we got to catch today. I promise you. But they're very fundamental key things. First off, a quadratic function is this right here. Y equals ax squared plus bx plus c. If I covered that part up and all you had was bx plus c, it would be a linear function. So All of your academic career in mathematics so far has only been this, the C and the B and the X. When I move my finger, oh, we have that. That right there, the x squared, that's the key. You see the x squared? What's the key? X squared. That's what makes it quadratic. So a little bit about it. The graph of a quadratic function is U-shaped. That U shape is called a parabola. Say parabola. Say parabola. I really don't care how you say it. The correct way is parabola. You hear a lot of people like, well, it's the parabola. If you look down here at the bottom of the page, there they are. There is those U-shaped parabolas. One's opening down, one's opening up. Where have we, we'll get to that in just a minute. And then the lowest and highest point on the U is the vertex. Where have we also seen vertexes here lately? No. In math. What kind of graphs also had a vertex? There it is. We have a winner up front. Vertexes, we also saw them. Put a little note here, we saw this on absolute values. So this academic year, you've already dealt with a vertex, but it was a V graph for absolute value, not a U. Okay, but it's still the same thing. It's the point that it'll turn. It'll be either its max or its min. All right, so a little bit of definition here. Like we said, without this part right here, this is what you've been doing. The C is some number without a letter. That'll be called your constant. Don't forget that. That's homework questions. That's a test question. This thing right here with no letter is called your, say it with me, constant. Linear term, that's x. What is this? What's this invisible number right here? X to what power? 1. So you've done that a lot. X to the first power. That's your linear term. Then there is the quadratic term. Look at it. Smile at it. That's what makes you now in quadratics. You have an x squared. So these quadratic functions, like we said, produce parabolas or a parabola. They have some parts. They have an axis of symmetry. It's the line that divides a parabola into two parts. So right here, this one's axis of symmetry would be the y-axis, and this one's axis of symmetry would be the y-axis. What would that be? Write this equation right here. X equals what? What is the equation right here for this line? That's the y-axis. X equals what? 0. Good job. So not always will the axis of symmetry be x equals 0 or the y-axis. Only when the vertex is laying here on the y-axis. This one's vertexes, and both their vertexes are 0, 0. You agree? All right, turn the page. We got more. Here is a quadratic function. How do I know it's a quadratic function? Yeah, we got a quadratic term, don't we? What do you think? Does the graph open up or down? Hey, good job. Why do you know this one opens up? Ah, very good. Right here, this is positive. So it opens up. Put a note there to yourself. Anytime, like, good job, James. And you might start to see a pattern. Absolute value graphs were the same way, weren't they? That leading coefficient up there, if it was positive, it opened up. If there was a negative sign, it'd flip it and open down. That pattern will be there all through this textbook, guys. Okay. What is its axis of symmetry? Right here. Axis. Give me an equation for the axis of symmetry. X equals 2. It's right there, isn't it? You notice it's dashed. X equals 2 is a vertical line. Okay. What is the vertex of the parabola? 2, 0. Very good. So label these, answer these questions there in your book. These are test questions. You'll have to do that exact thing. Understand, this is talking about understanding when you're looking at a parabola, knowing its parts, knowing its anatomy. It's like if any of you guys ever want to work at a veterinary clinic. When you work at a veterinary clinic, it's a lot about knowing the terms. Not like a surge tech. We have surge tech program around the corner. They have to understand what all the things that are called in surgery. So if the doctor calls for a particular tool, they know what it's called. They can grab it quickly, hand it to them. Knowing the parts. Don't you feel smart when someone's having a conversation and you know what they're talking about? Like, I don't feel that way very often. When people start talking about technical things, Dustin Verser does it to me, for goodness sakes. He'll start talking about things that he knows, and I'm like, I don't even know what he's talking about. But hey guys, I'm not afraid to ask. I'll just say, all right, what does that mean? I don't know that. All right, so there's the anatomy. Real simple example. Here's the anatomy. Some things you'll need to know. Now, some of y'all told me you've heard of FOIL before. Backwards FOIL is a method of factoring, but it's also known as a way of multiplying binomials. I know you can't read that, but write that part right there. That's the key. Regular FOIL is multiplying binomials. Raise your hand if you've FOILed at least once in your life in some class. Some have, some haven't. Okay, we'll talk about it. FOIL is there's a word for this where each letter stands for something. I think that word is called Pythagorean theorem. No, that's not right. What does it mean if every letter in a word stands for something? Is that called hyperbole? Oh, that sounds better. Let's go with acronym. FOIL is an acronym that stands for first, outside, inside. I normally say outer, inner. So just so you know, if I say outer, did I just spell otter? I don't know. Inner, I don't know what I spell. If I say outer or inner, I'm referring to outside and inside. So this comes out of your homework. An example here, x minus 2 is a binomial. That's an expression with two terms, a linear term and a constant. But it doesn't matter if it's a linear term and a constant, it's just two terms. And x plus 4 is a binomial. That means two terms. And if I'm going to multiply binomial times binomial, I can use first, outside, inside, last, or first, outer, inner, last. So walk through this with me. You realize that the x and the x are the first part of the binomial. So what's x times x? X squared. What would be my two outside terms? Somebody help us. This x and this 4. So what's 4 times x give us? 4x. Write this down. It's the only way you learn this. What would be my outside? What would be my inner terms, my inside terms? Negative 2 and x. So these were the outside, these were the inside. Negative 2 and x gives me negative 2x. What would be my last terms? Anybody? No. Negative 2 and 4, my last terms. Yeah, which gives us negative. So these, if x and x are the first, negative 2 and 4 are the last. First, outer, inner, last. All that is doing, if you follow this F-O-I-L, if you follow that, watch what F and O are doing. X times x, x times 4. That's F and O, isn't it? Look what I and L are doing. Negative 2 times x, negative 2 times 4. You realize that F-O-I-L is just simply taking this term and distributing it to both, and then this term and distributing it to both. Does that make sense? And what is this? Adding, multiplying, dividing? What are we doing with F-O-I-L? What are we doing? Multiplying. We are multiplying. Please understand that. I have students that struggle with that. They'll try to add two things. This is all multiplication. And you might notice We talk about terms. What kind of term is this? Quadratic. What kind of term is this? Linear. Linear. Constant. So these two are both linear. They're both x. So that means we can combine them to make 2x. Does that make sense? Okay. You will do more of this. That was a brief introduction. Turn the page. All right, here at the top of this, it says determine whether each function is linear or quadratic and identify the quadratic, linear, and constant terms. So we have A, B, and C. This is right off your homework. You have these kind of things. Here's a function that has some stuff. Here's a function with some stuff, and a function with some stuff. Does this one look like what we were just doing? Binomial times binomial? It does. This one does not look like that. This one does not look like that. They're a little bit different. What do you think about the first one? Somebody tell me, with your math skills, what should I do to this first function in order for me to know if it's linear or quadratic? Look for x squared. Do you see any? Yes. So is it quadratic? No. Now that's kind of got you tricked. There you go. Wait a minute. It's got a quadratic function. You're right. It does. So what might I be missing for that one if it isn't quadratic? It doesn't have a constant. That doesn't matter. It has a linear. I'm saying, what am I not realizing? Not necessarily missing out of the function. What am I not realizing? I'm telling you, this one's not quadratic. Nope. The constant being there or not being there will not matter. No, because it's a minus sign. It's not distribute. Add the x squared and the 5x. You can't do that. You can't add terms that aren't alike terms. I'm glad you guys are saying all this stuff. This makes me think of what you might or might not do.
If you add the negative x squared to x squared, it becomes 0.
That's right. Now, you remember those properties of addition. This is addition, then minus. We can pretty much just drop those parentheses. There's nothing there to add. Wow, Matthew, way to go. So if we realize there's 1x squared, there's negative 1x squared, those cancel. We're just left with 5x. Now what does it look like? It is linear. It's a linear function. And the linear term is the 5x. That's the only, we don't have a quadratic. We don't have a constant. You know what? Check this out. Somebody pointed this out to me earlier today. Let's see here. Clear this. Delete all. All right, if I had a graph like this, and I'm going to add just a function on there. If I was to add that into my calculator, I'm going to do it for you. That's what it says, isn't it? I wonder what it would look like. Are your brains wondering? There's the function. I put it into the calculator. I hit enter. Does it look quadratic to you? No. You know what it looks like? It looks like a line that has direct variation because it goes to the origin. And it's really steep. You know how steep it is? Got a slope of 5. It rises 5, runs 1. That's linear. That's what you've done forever. Are you with me? Come on, guys. Come on, stay with me. Y'all are the smartest kids in the county right here. I need you to stay with me. All right. So even my calculator knew, oh, those two terms are going to cancel each other out. It's just that. Good job, good catch. Let's move to the next one. Can you guys apply that? I'm going to, right below there on your paper, foil it. And I'm going to come by and I want you to show me what that equals. Go ahead. I'm going to walk around the room. If you're watching the video, I'm sorry. Start finishing. And you need to remember to multiply. You didn't multiply. Good. Good. Yep, that looks right. Yeah. 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 Where is it? Wrote anything down that I've given you? I'm working on it. You're telling me just quit taking notes, Mr. Bush. Good. Okay. Let's see. Get it? No. You have combine line terms and then what's that right there? Okay, wasn't it 4? Yeah, it's not 4, is it? It's multiplying. Okay. Looking around, I see some good stuff. First thing here, first is what? Someone tell me. 3x squared. That's 3x times x. What's outer? Oh, outer is minus x. Inner. Good. Last. Very good. We have a quadratic term. We have a linear, and a constant. Let's combine those. I think everybody here had minus 16x plus 5. So your quadratic term is which one? Oh, that's a squared. What's your linear term? Negative 16x. And the constant is the 5. Those are ACT questions too. This kind of stuff right here, just understanding different kinds of terms. Knowing if you were looking at a polynomial, somebody said that earlier, I think, or maybe it was in the morning. They call those polynomials. That's a quadratic polynomial. And knowing which term in that polynomial is the constant, the linear, and the quadratic part. All right, the last one. The last one does not require FOIL because there's not a binomial times a binomial. What property do you think you're going to throw in here? Very good. We're going to distribute. So we're just using distributed. And what do y'all end up thinking it'll be? Oh, I should have wrote that that's quadratic somewhere. X squared plus 3x. Very good. X times x is x squared, and then x times 3 is 3x. That is also quadratic because it has an x squared. What's the quadratic term? What's the linear term? Woo, 3x, that's an x. What's the constant? 0 or NA, there's not one, is there? Nothing. Very good, very good. All right, one more thing, and then we'll stop for today. One more thing here. Down here at the bottom, you see a couple what? What do they call these? They call them a couple parabolas. Parabola. Hey, on your paper, this is a great idea for math. We're only going to do this first sentence. Identify the vertex and the axis of symmetry for each parabola. So these parabolas, their vertex are not the origin. They've been shifted. So first thing, let's identify the axis of symmetry. Over here, woo, I gave you too much of a hint. What would I call the axis of symmetry for A? X equals 1. There we go. It's always the equation of a vertical line because it's an axis. It's a line that the right side of the parabola and the left side of the parabola will be symmetric. As this parabola moves up this way, you know it'll have an exact reflection across the axis of symmetry on this side. What about over here? What's its axis of symmetry? There we go. X equals -1. And one thing you'll notice is the vertex falls on the axis of symmetry. Right? It has to. So what the x coordinate is, what your axis of symmetry is, will be the x coordinate. There's the vertex. Y'all agree it's 1, -1? And you notice that the x coordinate of the vertex is the x. It's on the axis of symmetry at x equals 1. Over here, the x coordinate of this vertex is -1, which also falls on the axis of symmetry of x equals -1. Those always have to be that way, because your axis of symmetry always goes through your vertex. Y'all good with that? Okay. We'll stop right there for just a second.